Recording in progress.
Wah, nggak bisa nih kayaknya, guys. Tes 1, 2, 3. Suaranya ada nggak sih? Oh, ininya gue gini ya, tandanya ya.
Selamat pagi. Good morning.
Selamat pagi, Bu Veronica.
Ya, maaf saya tidak punya video karena saya masih recovering ya.
Oh, it's okay. Get
Ya,
well soon.
ya, thank you. Is Pak Diego already here?
Yes, I'm here.
Hey, how you doing?
Good, good. Selamat pagi.
Thank you. Yeah, thank you for doing this lecture. And Pak Diego, I will be, no video tonight because I'm still not feeling well. So, but I want to listening this one to make sure that, you are here and everything is okay. But yeah, I'm here to listening. And maybe Pak Said already here as well. And maybe Bu Rizka, silahkan. Terima kasih.
Mr. Z, are you here? Sepertinya belum ada, Bu, Mr. Z Alami.
Christine here, so he will
Oh,
join
Bu Christine here.
exactly at
Silakan Bu
9.
Christine.
So he will join exactly at 9.
Oh, okay.
Yep. Because
Okay.
for today, he will only have 15 minutes. So let's
okay,
make
okay.
use of this opportunity. Okay.
Okay, maybe we can start right now.
Yeah.
Good morning to our listening guests in Indonesia and good evening to our listening guests in America. Welcome to this International General Lecture Series with a Boeing Indonesia Association. We are honored by your presence in online. Today for Season 7, we will explore the theme of experimental flight tests. Allow me to introduce myself. My name is Rizka, who will be the host of today's event. It is with great pleasure that we introduce our listening guest, Mrs. Veronica Andrew, MBA, as a President of Boeing Indonesia Association, Mr. Zaid Alami as a Country Managing Director, Boeing Indonesia, Mr. Diego J Bernal, BA, as a Flight Test Engineer, Instrumentation Architect, Boeing Commercial Airplanes. Before we continue, let us all sing for our national anthem, Indonesia Raya.
I think you are muted.
Okay. Opening speech by Mr. Zaid Alami as a country managing director. Ladies and gentlemen, please welcome Mr. Alami.
Zaid, are you here yet? Give me a second. Zaid, are you joining yet?
I think he's not yet to join us.
Not yet joined.
Not yet.
Okay.
Good morning, Mr. Alami, or good evening, Mr. Alami. Are you joining us? I think he is right. I think he is there. He's in here. Mr. Alami, are you here?
Zaid, can
Hey,
you
can you
hear
hear me?
us?
Good morning.
Okay.
Okay, good. The stage is yours, Mr. Alami.
Awesome. Thank you very much. Sorry about the delay. Can you see me as well? Yes, okay. Well, selamat pagi para hadirin. Saya Zaid Alami, Country Managing Director dari Boeing Indonesia. Thanks for joining us today. I see we have about 91 people or so. And I also see my friend, Pak Diego. It's been a while since we worked together. We used to be on the same team. So he's going to be talking to you today about flight tests. But thanks you all for joining us today from Surya Dharma University. It's really great to engage with you all and talk about Boeing and talk about the aerospace industry and talk about how exciting it is to be a part of this organization and part of this industry. So I think to start, we quickly have a quick video that we would like to show that covers and highlights our efforts that we've been doing in Indonesia. And while that loads up, I'm really excited to see all of you. This hopefully is a there we go.
Boeing culture is so much ingrained in Indonesia's culture. We use the term kekeluargaan or people-oriented.
It's a place where we work and we have a business, but we also live here.
In work, I do engineering, and then in my spare time, I connect the Boeing products into art. I want to create identity of Indonesia inside of Boeing.
And liftoff.
Indonesia is the fourth largest population in the world, a vibrant democracy, a G20 country with a rapidly growing economy. 17,000 islands, much of it connected by aviation. Boeing has more than 7 decades in Indonesia. We have established our permanent office in Jakarta to further support the aviation ecosystem in Indonesia in the defence space, commercial space, training, supply chains and industrial partnerships.
Field service, we are the face of Boeing to the customers. Trust you earn every day.
Our customers require excellence in quality and perfection in every product that is made here in Indonesia, in my country.
Boeing is more than just a company. It works with the Indonesian people. It helps develop Indonesian society.
What I see now, I see more women in two step. If you want to become a pilot, girl, you go for it. You can achieve any dream you want.
Boeing Indonesia is a partnership primed for growth. Our partnership spans all different disciplines. We're here to support our customers and learn from the Indonesian people. There's a specific term that resonates with me, which is gotong royong, which means lifting together, and it's really about working together towards a common goal.
Thank you so much. So that's a very exciting video. Thank you, Christine, for putting this together. And before we start, I just want to quickly mention that I'll speak for a few minutes.
Airport.
I think the next YouTube video started. Yeah. So I'll speak for a few minutes. No problem. I'll speak for a few minutes, and then I would like to have this as a conversation. So please ask questions. And I'll be happy to answer some questions before we transition over to my friend Diego to talk about flight test engineering. So, a quick short story. I used to work with Diego in flight test engineering many years ago, and then we partnered together throughout the years, but it's really good to see him here in my current role talking to our Indonesian future leaders. And a quick point before we start. I would like to highlight Pak Ade from the Boeing team, who's on the phone right now. Pak Ade is a graduate of Surya Dharma University, and he's currently one of our flight ops engineers working for Boeing here in our Indonesia office. So thank you, Pak Ade, for showing them the example that you too, when you graduate, could potentially join our great company here in Indonesia. So to start, let's talk about Indonesia and our presence. So we've been here for 75 years. This year, we celebrated our 75th anniversary. We first came to Indonesia when we delivered the first aircraft, the first Boeing aircraft, in 1949 on January 26th, and we've been here since. We have, of course, gone through different phases, but we've always had people. And in 2021, we declared Indonesia a strategic country for Boeing, and we opened our corporate office. The corporate office is in Jakarta, and hopefully one day your team, all of you can come visit us, and we can schedule something and get together and have a session together. Since we opened this office, we've expanded our presence. We've hired a number of engineers in different disciplines, established an engineering center headquartered in Jakarta that covers the region, that has flight ops engineering, like Pak Ade, systems engineering, structures, reliability, maintenance programs, propulsion, air traffic management, supply chain, regulatory affairs, flight ops, and I can keep going on and on and on. So we're very committed, and there's a reason for that. When you look at the current slide that you have in front of you, this is a map of Indonesia. Of course, all of you Indonesians know this, but I, didn't know this until recently, which is the world map that we know it is not up, to scale. It's not drawn to scale. Indonesia is a lot larger than when it actually looks on the map. And when we started thinking about this, we realized that, according to IATA, the International Air Traffic Association, Indonesia is going to be the number 4 largest market in the world by 2036, which is only 12 years from today. It's happening very, very fast. So we're looking at a tremendous amount of growth coming to this country. And there's a few reasons for that. Before I get into the reasons, let's talk a little bit about the commercial airplanes division at Boeing. So in Indonesia, there are 800 registered aircraft, only of which 400 are active commercial jet airplanes today. Pre-pandemic, that number was about 600, so we're still down about 200 airplanes when it comes to the commercial side that are in the aviation ecosystem here in Indonesia. We project a need for more than 1,300 airplanes over the next 20 years. So we're looking at a 3 to 4x growth in commercial aviations over the next 20 years. So you guys that are, at Surya Dharma, that are studying engineering or interested in aerospace, you have a great advantage in timing your industry, because it's only going to grow. There's going to be a lot of opportunities. We need all of you. There's a global 2 million person shortage that is supporting, that is needed to support the aviation industry over the next 20 years. And I encourage you to go to the Boeing website and search for a term called CMO, or Current Market Outlook, and Pilot and Technician Market Outlook. And you will be able to see all these numbers and analysis that look at every region and analyze what, how many people we need and what are the gaps and where we need to be. So, going back to the growth that's coming to Indonesia as the fourth largest aviation market in the world, there's a few reasons for that. The first one is geography. But before we dive into the geography, let's look at the map that we have here in front of us. So every black dot is an airport in Indonesia. Anybody can guess, and please write it in the chat or go off mute if you'd like, and tell me how many airports are there in Indonesia. Any guess? Let's see, I'm pulling up the chat to see if anybody is courageous enough to attempt to answer. And if you get it right, I will make sure that Ibu Christine and Ibu Veronica will send you a Boeing gift. So somebody's off mute. Anybody can guess? There are 112 people
Maybe
here.
I'm gonna try it, Mr. Alami.
Yes, Ibu Rizka.
Maybe
Please repeat the
600
question.
over or more. 600
Sorry.
or more
Would
or
you like
less.
please
Maybe.
to repeat the question?
Yes, we will repeat the question. The question is, how many airports are in Indonesia today? And Ibu Rizka, what was your answer? What was your guess?
600 more, maybe
600,
more
than
than
600.
600. Yeah.
Okay. Anybody else? Okay, I see somebody that says 683. That's a very exact figure. I think, did you use Google to look that up? Because both you and Ibu Rizka are right. This is the first time ever that somebody answers this question correctly. So I will make sure that Ibu Christine helping me here is one of our senior principal engineers at the Boeing Indonesia office is gonna help make sure that both of you receive a quick prize for answering the question correctly. And I see is it Pak Ishwan is from BRIN. So BRIN is the research institute in Indonesia. Are you from BRIN, or are you a student at Surya Dharma?
I am from BRIN, sir.
Okay, so that explains it. That's why you know, right? So thank you very much for joining us from BRIN.
Yes,
it's really good to see some of our Indonesian experts that do all the research on Indonesia in the room joining us today and to learn about the aviation industry. But I think you can teach the next lecture, so maybe we'll invite you next time. Yeah, so you're right. There's 683 airports, and on this map there are 300 airports. So this is only 50%. And when you start thinking about the geography of what drives this country to become the fourth largest aviation market in the world, first you look at the longest domestic flight. Anybody can guess, and please put it in the chat, how long it takes to fly from Papua to Aceh? So all the way in the east, from Papua all the way to the west in Aceh. How many hours nonstop? If you get on a Boeing airplane today and you head west in Jayapura, how long does it take you to get to Aceh? 4 to 5 hours. Anybody else? Let's see if Pak Ishwan from Bryn can answer the question again. 9 hours from, okay, 6 hours. So good. I want to see more interaction. So please get ready to answer some more questions. So it takes about 8 hours to get from the east to the west. It's a very long journey. And that's, one of the reasons, Indonesia is a very big country with 17,000 islands, 6,000 of which are inhabited. And really the only way to connect those islands is aviation and airplanes. And that's why we see a tremendous amount of opportunity here. When we start thinking about the other reason, it's the population, right? You have a large number of people, 280 million people, 35 million in Jakarta, in the Jakarta. It's the second largest city in the world, metropolitan area, 35 million people. 70% of the 280 million people are under the age of 39, are you guys. So that demographic bonus is going to continue until 2047, I believe. And this is a great economic booster to the industry, because it will make sure, as more people grow up and want to travel and be productive, then, the aviation industry is only going to boom. And then the other factor is really the economy. We have a lot of great GDP growth. It's the 16th largest GDP in the world, and we're seeing 5 to 6% GDP growth per year. And aviation is growing at 11.9%, so more than double what the GDP is. That's fantastic news. It's really encouraging to see those numbers, and we're looking forward to continue to play a role and help enable and unlock the growth for Indonesia. So, one additional thing, I'm going to quiz you, and you guys are going to need to put this answer in the chat, and then I'll come back and reveal the winner later, the prize winner later. What is the busiest air route in Indonesia? So 2 airports where at least one of them is in Indonesia with the highest number of flights. So please guess that. So in the chat, I want you to put the name of 2 airports, at least one inside Indonesia, with the highest number of flights per year between these airports. The most in Indonesia. So please start writing in chat, and I'll pick a winner in the next few minutes as I continue my remarks. So I see that some answers starting to come in. Great. So, when it comes to defense, Boeing looks at Indonesia because Indonesia is the largest defense market in Southeast Asia. We're currently working with President-elect Prabowo on finalizing the deal that we signed last year when he visited our factory in St. Louis to acquire a number of F-15EX future generation fighter jets. And these airplanes are have the best range payload in the industry. And what's very interesting as well is Indonesia has a law that requires any defense sales to have an offset, an 85% offset, which means that anytime we sell something to Indonesia, we have to invest a certain percentage of that sale into Indonesia. And that's really exciting because we're going to be working with your government, the KKIP, and making sure that we invest in the right areas that will help Indonesia grow and become the major aerospace player that it's on its way to be. When it comes to supply chain, so you can also start guessing. I see some good guesses in the chat, but you can also start guessing how many parts is one Boeing 777 made of. So just put a number. How many parts make up one airplane? Put a number in the chat, and we'll also pick the winner in a little bit. So with that being said, we make parts all over the world. And we have suppliers in more than 135 countries, which are 20,000 suppliers making parts for each Boeing airplane. Those suppliers in Indonesia, we have some of those suppliers, but in Indonesia we have only 12 aerospace approved suppliers. When you think about it, compared to the US, China, and India, the top 3 markets, where Indonesia is number 4, remember? Those top 3 markets, the lowest one is India, and they have 1,300 suppliers versus our 12. So we're a very far distance away from where we need to be when it comes to the number of suppliers. Additionally, when you think regionally, we have, when you compare it with Malaysia, Malaysia is a country that's much smaller to Indonesia with a much smaller GDP, yet they have 300 suppliers and we only have 12. So we are working together with the industry, with the government to grow that number. Just a couple of months ago, we held a conference in Bandung and we invited a number of key players. And I'm very proud to say that today we were already, in a short couple of months, we were already able to support 3 new suppliers join the aerospace industry. And now we have 15 aerospace suppliers, but we still need 1,000 more or more. So let's keep working together to figure out how we can grow the supply chain industry in Indonesia. And lastly, I want to talk about is STEM. We're very focused on STEM education and STEM outreach. You know, this initiative led by Ibu Veronica is a great initiative where we partnered with 11 universities to help join them and talk about Boeing and the aviation industry. And today you're going to learn about my favorite part of Boeing, which is the flight test organization and what we do and how we test experimental airplanes to make sure that they're safe and certified to operate, and how we bring new technologies to the market. And you know, we also established Boeing Indonesia's first internship program this year, where we had 2 students join us for 3 months in our Boeing Indonesia office and go to the United States, to California and to Seattle, and spend 1 month there supporting our engineering teams there as well. So please, you know, follow me on LinkedIn and on Instagram, and we will be posting the next cycle, which will be coming up soon, on potential interns joining the Boeing company in Indonesia. We've also, I'm very proud to say that with the help of Ibu Christine on the phone, we were able to launch the first Boeing Women Inspiring Leadership or discussion just on Monday this week. We had the Deputy Chief of Mission of the United States to Indonesia, Miss Heather Merritt. We had Ibu Polana Pramisti, the CEO of Airnav Indonesia. We had one of the Boeing executive leaders, Ibu Nell Breckenridge, and we had one of our engineers, Ibu Ruth Manik. And finally, one woman 737 next generation pilot from Garuda, Captain Alendia. They all joined us together in our office and talked about the importance of having women in aviation and why we need women in aviation. We are fully, you know, Boeing is fully supportive of that. We're very excited to have more future events like that, and we would love to see all of you join, women and men, because also men can be great allies to support women's growth in aviation. We had a challenge, and we succeeded with the challenge on Monday, where we're going to start launching the Women in Aviation International Indonesia chapter. Once we launch this, we're going to invite all of you to join this chapter, and we'll have regular, agendas or meetings or discussions about supporting women to join the aviation industry. And we also are currently in the process and working with your university, Surya Dharma, and others on launching Boeing's first scholarship program in Indonesia, where we will be picking 12 students per year to support them in their tuition and their journey through their aerospace engineering and STEM journey education. And yeah, so that's a quick overview on Indonesia and what we're doing. Of course, we have I touched on the commercial airplanes. I touched on some of the defense and space and airplanes, but I haven't talked about space yet. We've been partners with Indonesia in space for more than 40 years. We delivered Indonesia's first satellite in 1976, and Indonesia is the first developing country to operate its own domestic satellite network. We're very proud to be a part of that network and support that goal. We have a future satellite launch that we're currently still building in the factory. So stay tuned and follow me on LinkedIn and on Instagram. And when we have the launch, we're probably going to get together in Jakarta somewhere and look at the launch and watch it together and bring some experts to talk about this launch. Finally, we have sustainability. Sustainability is a very important thing when it comes to aviation and when it comes to Boeing. We have a sustainability strategy that's focused on decarbonizing aviation before 2050. When it comes to aviation, aviation makes up about 2.4% of greenhouse emissions globally, which is a very small percentage. But as other industries grow or decarbonize, then that percentage will grow. And therefore, we're very focused on making sure how we decarbonize aviation. There's 4 pillars in our strategy. The first one is fleet renewal, which is basically replacing old airplanes with new airplanes. Every new generation model airplane from Boeing will improve fuel efficiency by about 20 to 30% and hence decrease greenhouse emissions. So that's the first pillar, is about 20 to 30%. The second one is operational efficiency. When it comes to operational efficiency, we have a number of technologies that are focused on optimizing the flight path of the airplane during flight and throughout the whole life cycle of the airplane. And that is responsible for about 10% reduction in greenhouse emissions. That means the airplane doesn't have to wait in the sky or hold before it lands. It goes the most direct route. It doesn't mean it's the shortest one, but we look at wind. We look at different elements in its flight path and make sure that we optimize it for sustainability. The third pillar is renewables. One of those major investments that we're looking at is how to look at SAF, sustainable aviation fuel, as a major enabler to our decarbonization strategy. Sustainable aviation fuel is a fuel made from many different ways. There's 7 different technical pathways to make it. And it can be from agricultural waste, like coconuts, that was just approved in March, or corn husk, or whatever it may be. It can be made from municipal waste. It can be made from different chemicals that are transitioned into fuel, but it's sustainable. And that's responsible for about 80% reduction in greenhouse emissions, a tremendous amount of reduction. And something that you probably didn't know is that there are all Boeing airplanes today are capable of running on 50% SAF today. And by 2030, all Boeing airplanes will be capable on running on 100% SAF. So we're committed there. The issue is we don't have enough SAF. So that's why we're very focused on SAF as an enabling SAF as part of our strategy. And then at the end, we have our advanced technologies, which is, we're looking at the X66. I'd encourage you to Google that. The X66 is a sustainability aircraft, the first aircraft X-plane with NASA that's focused on sustainability. We have a long and thin wing supported by a strut, and that is responsible for about 30% reduction in greenhouse emissions. And so is like electric technology that we're looking at with our subsidiary Whisk, where we have a fully autonomous, no pilots, fully electric air taxi that's for use for advanced air mobility.
Your presentation slide is not changed. Still the first slide.
Correct. The slide is not changing because I don't have another slide. I'm just talking. So I want to have a discussion more than a presentation. There's this term called death by PowerPoint. I can give you 100 slides, but you'll be bored. So it's better to have a conversation. Thank you for pointing it out, though. So now that I'm done with commenting about that, I'm going to look at the guesses. So we have Jakarta, UPG, a lot of Jakarta Medan, Jakarta Kuala Namu, Jakarta Bali. I'm really sorry to say that all of you are wrong, because the busiest air route in Indonesia is Jayapura, Wamena, all the way in the east of Papua, 34,000 flights per year, about 90 flights per day, flying on a 737-300 passenger to freighter conversion. And this is a cargo airplane that you're seeing on the screen, a 737-800 BCF, which there's a few of those also operating in that region. And for Pak Fakri and Pak or Ibu, I'm not sure, Moch and Pak Asif, you guys are all right. It's 3 million parts for the 777. So thank you very much for this. Any questions? I'll take a couple questions if anybody has some questions.
I have a question.
Yes, sir.
What I see in my laptop is a picture of Boeing 737. How do I change this before I ask question? Anyway, I will ask question. We met, Mr. Alami, last Thursday. My name is Edi Alimin. Remember Thursday night?
Thursday night. Where? Tell me where.
Global partner meeting.
Yes.
Okay, I'm part of Surya Dharma. I teach here. My question is, you're talking about supplier for Boeing. I know that cooperation between, let's say, OEM and other partner usually have very limited technology content when doing business, because technology is it's kind of limited and expensive. My question is, what type of, let's say, part of anything that supplier can provide to OEM like Boeing that have kind of technology? I try to do. I teach in Surya Dharma, but I try to set some doing some supply chain. Of course, students can get in, participate in it. But my question is that if the supplier contain high technology, is it possible? I mean, is there any limitation where technology can be supply, or because usually a big original equipment manufacturer like Boeing doesn't usually exchange technology. That's my question. Hope it's very clear. My question.
Yeah. Thank you very much. Yes, absolutely. We have 20,000 suppliers in 135 countries. They are all kinds of suppliers. Some people that are supplying pencils to Boeing, and some people are supplying flight computers to Boeing. So yes, there are plenty of parts that are supporting our operation when it comes to our avionics business, and same thing with our structure parts and engines. And one of our biggest suppliers is an engine manufacturer. They provide us with an engine, a complete engine. That is, I would say, the top technology that's out there to enable our airplanes. So yes, thank you very much for the question. Anybody else has any other question?
Maybe we can.
Yeah, thank you for the chance.
Okay, maybe for the last question, Mr. Indra Purnama.
Yeah,
so sorry
thank
for
you.
Fahri. We can
Ibu.
to make you question. Okay.
Yeah, one of the most interesting event of Boeing in the world today is the Starliner event in the outer space. How would you like to explain about the stranded astronauts in the International Space Station related to the Boeing technical reliability? Thank you, sir.
Thank you very much for the question. And can you just introduce yourself? Where are you from? What do you do?
Oh yeah, my name is Muhammad Indra Purnama. I'm an airworthiness inspector in Kantor Otoritas Bandar Udara Soekarno-Hatta, Airport Authority, Regional 1, the first class regional authority. But don't take it wrong. Even though the name is Airport Authority, but actually we also handle the airworthiness matters. So I myself is an airworthiness inspector. It is part of the DGCA of Indonesia. And I think one day we want to invite Boeing to our office to share many knowledge and best practices to make us more understand each other. I think if you have time one day. Thank you.
Gotcha. Thank you very much for the the introduction. And I wasn't aware that this session is not for students. I thought it was for students. So if I was aware in advance, then I would have would have changed some of my content and tailored it for not students. So my apologies about that. But
no
as
problem.
far as
Your presentation is great. No problem. Thank you very much
Thank
for
you.
your sharing.
Thank you. Yeah, as far as Starliner, to answer your question, Boeing continues to focus first and foremost on the safety of the crew and the spacecraft. We're executing the mission as determined by NASA. NASA is the prime contractor, and that's who makes the decisions and executes it. And we are preparing the spacecraft for a safe and successful uncrewed return to Earth. So we're very supportive of the NASA mission, and we are actively working together. But we have to work together, and this is space. Space is a very interesting place, and we're very fortunate enough to be partners with NASA, and we happy to collaborate and continue to collaborate with both NASA on their space program, as well as Indonesia with their space program. And this really highlights the long history of Boeing in Indonesia with 40 years of space. We've delivered the first satellite, Palapa 1, in 1976. And then since then, we're currently building Nusantara 5, right? NSL 5. So this satellite is a 702 satellite from Boeing, built in our El Segundo operations in California. And we will be launching it from the United States with one of our partners early next year, probably, depending on our customer here in Indonesia, the Indonesian SOE, PSN, and so on. So we're very happy to be partners with Indonesia across the different business units, whether that's commercial airplanes, defense, and space, and as well as our services industry. And we look to continued growth in that arena. Thank you very much for the question. Anybody else, or is this it? I'm worried that Ibu Rizka is gonna shut me off. So
Yes, I'm sorry.
Thank you for
Maybe we
your
can.
answer.
Thank you very much. Thank you, Ibu Rizka.
Okay, thank you very much. Maybe we can end the session for Q&A, Mr. Alami.
Yes, thank you very much.
Okay.
Great to talk to you all, and hope to see you again soon. Thanks.
Thank you very much, Mr. Alami. I didn't expect you to be so fluent in speaking Indonesia, but thank you for making this lecture interactive with your question. We're looking forward to the prize, Mr. Alami, through Mrs. Veronica or Mrs. Christine, maybe. But anyway, thanks
Yes,
again,
they
Mr.
can.
Alami.
They can help you. They have the
Okay.
prizes, and they can send them to you. Thank you.
Okay, thank you very much. Before that, we would like to invite all participants to join us for a group photo. Please kindly turn on your camera. Ready? 3, 2, 1, smile. We will take one more just in case. 3, 2, 1, smile. Okay, thank you very much. Before we continue to the main session, allow us to introduce our moderator for today, Mrs. Syarifah Fairuza, STEMT. She is a lecturer of the study program Faculty of Aerospace and Industrial Engineering. Are you here, Mrs. Syarifah?
Yeah, Miss Rizka, I'm here.
Okay. The stage is yours.
Okay, thank you, Miss Rizka. I will continue from now on. The honorable speakers, Diego J Bernal, Bachelor of Engineering. Distinguished guests, Rector, Vice Rector 1, 2, and 3, Dean of FTDI and staff, Mr. Zaid Alami, fellow students, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Good day to everyone. Okay. I'm Syarifah Fairuza, and today I will be the moderator for today's general lecture. First of all, welcome to our general lecture on experimental flight tests, a crucial aspect of the aviation industry. We are honored to have a representative from Boeing join us today to share their invaluable insight and experiences. Experimental flight testing plays a pivotal role in ensuring the safety, reliability, and performance of aircraft. It involves rigorous testing and evaluation under various conditions to validate design concept, assess aircraft system, and identify potential issues before certification. I am confident that Boeing's expert will provide us with a comprehensive understanding of the complex processes and challenges involved in experimental flight testing. Today, we are fortunate to have Mr. Diego J Bernal. Well, I will introduce him to you all. Diego was born in Bogota, Colombia. He graduated with a Bachelor of Engineering in Mechanical Engineering from the City College of New York. He also obtained a graduate certificate in Management Science and Engineering from Stanford University, a certificate in Project Management from the University of Washington, and a certificate in Test and Evaluation from the University of Alabama in Huntsville. Diego is one of the 2 senior leads or organization architects for NW Flight Test Instrumentation Operation in Seattle. Diego joined the Boeing company in August 2006 and flight test instrumentation in December 2007. His current focus is on developing a more comprehensive training plan, closing the training and development gaps, and improving the organization health. During his tenure in flight test instrumentation operational, Diego has led different flight test instrumentation programs and participated in several flight test programs where he selected and managed transducers, performed signal conditioning, design instrumentation and equipment installation, set up the data network architecture, and perform functional check for the instrumentation data system and its corresponding parameters or measurement. Today, we have the privilege of hearing from Mr. Diego J Bernal, a renowned expert in the field of experimental flight tests. Mr. Diego brings a wealth of knowledge and experience to these topics, and I'm confident that his insights will be both informative and inspiring. Before we begin, I would like to remind everyone to please turn off their microphone to avoid disruptions. And additionally, we encourage you to ask questions at the end of this lecture. Without further ado, let's welcome our esteemed speaker from Boeing, Mr. Diego J Bernal. Are you here, Mr.?
Yes, and thank you for such a nice introduction.
Okay.
Yes, and also it's pretty nice to hear from Said that he's here, and also the cool things that are happening in Indonesia with the Society of Women in Aviation and also all of the internships that are available. So my apologies if if my voice is not coming along, but I'm recovering from some cold. So
Okay.
let's see.
It's clear though.
Okay, cool. Okay, so let me share my screen. Usually I don't use Zoom. Let me find out where is the share button here. Okay.
In the bottom one.
Yes. Cool. Let me guys know if you see my screen.
Okay, we can see clearly.
Okay, awesome. So it is my pleasure to be here with you guys. So I've been, as you mentioned, I've been working at the Boeing company for over 18 years. Actually, 3 days ago on Sunday was my 18-year anniversary. So it's such a nice pleasure for me, and also being here with you guys and teaching you some of my experiences and my knowledge that I got throughout these years in experimental flight tests. So as I was introduced, I grew up in Bogota, Colombia, so I love salsa dancing, just in case. And as you guys, I came from a tropical place. I'm not used to this cold that I get here once in a while, but it's a beautiful place to be. Also, some spin that I'm gonna do throughout this presentation, you're gonna see some yellow stickers popping up in the presentation. And the idea is that I want to introduce some planning and strategic and leadership skills as well. Because usually as engineers, we focus so much on the technical aspect of everything, but in reality, once we start our work life, many things depend on how our skills, our leadership skills are, how good we are in communications, and all of those soft skills that usually people talk about. Okay, so on today's presentation, this is my agenda. So I'm gonna have an overview on experimental flight tests. I'm gonna talk about the purpose, the plan, the processes, and the people that participate in experimental flight tests. Then I'm gonna focus on some examples. Some of those are gonna be some highlights on the usual flight testing that we do. Also, we're gonna go into propulsion certification, and then we're gonna talk about some aspects of R&D, research and development, and how we use the eco-demonstrator for those. And then we're gonna go into a Q&A. So experimental flight tests. Okay. I guess most of you are college students, so I guess I don't know what years you are, what semester, if towards the end of your major. But usually many of you are gonna be listening about strategic planning. And when we listen about strategic planning, we need to have a clear vision of what we want to accomplish. Same thing happens with flight tests. We need to have a clear vision of what we want to accomplish. What are the goals of the tests we want to conduct? What strategies are we planning to use? What kind of sequences we're going to implement during testing? The people and the processes that are going to get involved during testing, how we're going to plan the resources and the locations and the facilities that we're going to use. So what is flight tests? What is the purpose of flight tests? So there are different aspects. One is validating and verifying the operational characteristics of a new airplane. Also, we want to demonstrate that the airplane fulfills their design as it was intended. And also we want to ensure that the airplane is reliable and that it's safe to use for commercial flights. Also, something that is very important about experimental flight tests is that we want to find or identify any airplane or any design issue that might happen. So for us, when we find that something is happening, that's the perfect time because we can redesign or we can talk to the different people in charge of this commodity so we can rework this part. Also, we do flight testing to perform research and development, and also because we need to comply with all of the regulatory agencies around the world. So we need to have a clear vision. So how long a flight test program is? So everything varies between a program and program. So I'm gonna show like the life cycle of the design of an airplane. So everything starts when the airplane program is launched. So as a company, we decide, oh, we want to design this airplane with these capabilities, for this amount of passenger, for this capacity, for this amount of cargo, whatever we intend to do. Also, oh, we want to be able to fly from this city to this other city around the world. There are so many requirements what we put together for this design, and we start creating this design, this new model for an airplane. And when this is happening, flight tests in parallel is going to be working with every single person that is working on the design of the airplane, because there are many things that need to be taken into account. Because in flight tests, we need to collect data. Our job is to collect data and data and data with the goal of proving that the airplane is able to perform with everything that we have said that it's going to do. So we need to install transducers. Those could be accelerometers, it could be thermocouples, strain gauges, stream pods to detect displacements, flow meters, and so on. So when they are designing the airplane, also they need to consider how we're going to install all of these sensors and all of these transducers that we'll be using for flight tests. So we work in parallel with the airplane program while the program is getting launched. So the program, when I refer to the program, I am going to say the people that is in charge of designing the airplane. They have a firm configuration. Flight test is planning based on that configuration that is being decided. And then let's put it this way. Any one of you has a cell phone, right? A smartphone. And you know that each cell phone has an accelerometer. Yeah. So just imagine having accelerometers installed in many locations on the airplane. So I need to be able on designing how those accelerometers, how those sensors will be placed in every single location that we're interested on the airplane. But then we need to take those accelerometers, we need to provide some wiring and go to some place where this signal is going to be treated. We're going to do some signal conditioning, and all of this data is going to get recorded. So if I'm designing a wing, I need to talk to the people that are designing this wing and see what they want to measure once the airplane is built. So also I need to plan on how I'm going to install those accelerometers on that wing to have less interference on the airplane itself. And so we have this going on. The airplane goes in final assembly. We work in installing all of this equipment, all of these sensors, all of this wiring on the airplane. That is only for flight test purposes. And that happens in concurrence with while the airplane is getting built. Once the airplane is built, a flight test is there, and we go all the way through the end of the assembly of the airplane, and then the execution phase of flight test in which we fly. So in flight test, we have a planning phase, a design phase, and a build phase, because there are many pieces of equipment that need to be built as well. And also we participate on the execution in the flight test program. And the goal at the end is having an airplane certification complete, and we need to have an airplane ready for delivery. And that's the overall map cycle on how a flight test program works. In the case of the 787, I think this one lasted maybe like 8 years, kind of. Some programs could be shorter. In some programs, I'm certifying only a couple of pieces, or if I'm working on a research and development program, it could be pretty short. So the length, it varies. So I guess most of you are like aerospace engineers or aeronautical engineers. In my case, I'm a mechanical engineer with an emphasis in aeronautics, but also we got many people in flight tests that are not only aeronautics or aerospace engineers. We have people that are manufacturing engineers, we have industrial engineers, we have electrical engineers, we have some people in mechatronics. We all work together and we have different functions. So what I want to show in this process and people overview is how the different roles and the different process interconnect. So when we begin a program, we have regulations, we have requirements, let's put it this way, that come either from the regulatory agencies, most of the time from the FAA, and also we have requirements that come from Boeing itself, because we have our own set of requirements that are very stringent, I think they are way tighter than the ones that come from the regulations. And we need to look at those. We need to see how we can implement instrumentation, how we can collect data that is needed for all of those requirements. So we have a group of flight test engineering that we call it flight test engineering analysis, that interfaces with these people that is providing these requirements. Also, we got other group of people that I didn't put it here, and we call test program integration and test program management. And they are going to be part of this conversation. And I belong to a group that is called instrumentation operations. And I come and I get part of this conversation, and it's like, okay, guys, do you want to measure this? What frequency do you guys need to measure this? What range are you expecting to see? Okay, I'm able to use this kind of transducers. We're able to use these, or maybe not. Maybe if you are interested in this frequency, we can try this different method. There are different things that we can do, and it's a conversation. Then we got ground operations. That is another part of our team that is looking into the configuration of the airplane itself. If anything is changing, what are we changing? What kind of weights we're involving? Are we moving parts? Everything that deals with configuration of the airplane. And we have our test operations or our test directors. And basically, I put it as an orchestra director that during the execution of the test is the person that will be talking back and forth, that will be making sure that everything that is talking to instrumentation, making sure that everything got instrumented, that the data is coming out right. He's talking to ground ops, making sure that all of the configuration paperwork is being aligned, that everything is being documented, and so on. And then we have the people that support our daily operations. We have industrial engineering, that they are going to be working with our schedules, the places we're going to be working on, and our manufacturing maintenance teams, because they are the ones that make everything happen. They are the ones that install our equipment, the ones that install our transducers, the ones that work on the airplane, the people that work in the shop and make everything happen. And I love working with them. Yeah, they make everything happen. But also we have different processes. So I had mentioned that we have requirements that come from the FAA, from EASA, from JAXA, from any of the regulatory entities, or from Boeing. So we have those processes that we have created to be able to document those test requirements. Once we're able to document those test requirements, we need to start planning. And that's where this flight test planning bubble here comes up. We got test requirements. Now we need to start planning based on those test requirements. But that test planning is, okay, do I need to design something new to be able to measure this? Do I need new sensors? Do I need new transducers? Do I need new signal conditioning equipment? Do I need some equipment rack to be placed on the airplane? Do I need certain locations to go and test? We're going to go a little bit on this later on, because there are certain locations that we go to because we might need some environmental conditions like high altitude, or maybe some pretty strong winds that we don't get here in Seattle. So that's part of that flight test planning. We take all of these locations, all of these environments, all of these requirements into consideration. And also we see how many people we got available, because we need to plan, but also we need to see the resources that are available. Then we work in test scheduling. We have our own procedures for scheduling testing, the airplane configuration, if there are going to be any changes along the way, if we need to change engines, if we're testing engines, how many engines we want to test. Then we start working on flight testing itself. And then at the end of flight test, we provide all of the data and the approval based on the results of testing. So there are two important parts. One is the process planning, and the other one is the people planning. And I guess for those of you that are in the industry, you know how important processes are, because if you don't have a process that is being well-defined, it might create a mess or it might create confusion. So we need to have processes that are documented and that are known by everybody. So far, any questions with you guys? Okay, so you might ask yourself, who flies inside the airplane during a test flight? So we have several people here. So I'm using this diagram, and usually we have the pilots on the front of the airplane, but also I mentioned that we have a person that is called the test director, the orchestra director during a test flight. The test director is gonna be the person that will be talking to the pilots, that also will be talking to us here on the back of the airplane. We got some people in the main cabin on some of the equipment racks that are the flight test engineer and analysis engineers. And also we have some people that we call the design engineers. By that name are the people from the different commodities that design certain parts of the airplane. So for instance, if I'm working on a propulsion test, the people that will be invited to be on that test flight are going to be the people from the propulsion team. And also we're going to have our flight test engineers from the analysis team that work in propulsion. So those are the ones here sitting on the back. And also there are two groups that on our Boeing flights are always present. One is a flight test instrumentation, which is my team, and also the weights and ground operations team, that they are in charge of the cabin safety of the airplane and everything that is in regards to safety during the execution phase of an airplane. So something that I wanted to put here to keep in mind is that flight test participants share the same attributes of a leader. And what are those attributes? You need to be an active listener. Just imagine you're sitting here on the flight deck, and you need to, when you're on a flight, usually as a passenger, you don't hear the control towers, but the pilots in the front, they have to have the radio on and listen every single communication that is happening. But also in a test flight, every participant needs to listen what's going on the airspace, what communication is coming from the control towers. We need to listen each other. We need to listen the information that are coming from the pilots, the observations that are coming from them, and also the information that is coming from the test director. So when you're on a test flight, you have to be very active and you have to listen 100% of the time, because you don't want to miss any data of information. You need to be able to communicate clearly what you see, what you find, anything that you see, you just need to speak up. You need to be a good communicator. You need to strive to be your best, because when you're in a flight, you're representing your team, and you're going to be that person that has to carry that weight and that responsibility. You need to be inclusive, and being inclusive is to have respect with everybody that is on the flight, because everyone has something to bring to the table during every single flight, and you need to be authentic. By being authentic, you just have to be yourself. You need to be a tough leader. Meaning tough leader is you just have to say what you see. If something doesn't sound right, you have to say it. If you find maybe some event, something that you were not expecting, you need to speak up, and you need to lead that conversation. Always, you need to continue training. We never stop training. There are always something new to learn. Even through my 18 years at Boeing, I'm always learning. It is always learning. It's nonstop learning. You need to make peer connections, and you need to find and emulate a role model. I think every single person needs to find a role model that can keep you on track and inspire you to achieve things that you want. So have you ever imagined that a experimental flight test airplane looks like this? So it doesn't have the comfy seats that you usually find. So those seats are not that comfortable. If you see, they recline well, but they are not that comfortable. And I'm gonna show you a video in a few. And we have a section in which we have a workspace where we sit, where we look at the data, where we look at the information. But if you look at these images, it is overwhelming because you see all of these racks full of equipment, full of wires, full of power, full of lights, full of equipment. And when you go to an airplane on the first time, it's like, wow, what is this? So let's not wait too long for this video. And let me see, hopefully the sound goes right.
Mr. Diego, we can't hear
Yes.
it. Is there any sound on the video or not?
There is sound.
But we can't hear it.
Okay, let me see what I'm supposed to do here on this so you guys can hear this sound. Usually I use a different platform that is called WebEx. Let me see. Let me find this. So how do you guys do when you are sharing videos so you guys can hear sound?
Usually it come along with the video.
Okay, so let's see. Let me do a quick change here.
Airplane. Behind me are the
What
black.
Okay, now we can hear it.
And this is the
Okay, I'm gonna go back to the beginning and
Okay.
let me know if the sound comes right.
we're on aircraft ZA001. It's the first flight test airplane in the 787 fleet. My name is Scott Peterson. I'm a test director for flight test. I'm just going to show you some of the ins and outs, what all these components are that you see in the airplane. Obviously, once you first step in, you can see it's not a typical airliner type airplane. Behind me are the black. These are water ballast tanks, and this is the way we control the center of gravity on the aircraft. So when we're on a forward CG, we fill the tanks up front here with water. They represent quite a bit of weight, which moves our center of gravity forward or aft, depending on the flight test we're doing that day. We're mid-cabin now on ZA1. This is the start of our instrumentation racks. This airplane has miles and miles of orange wire, you'll see. And all these orange wires go out to pressure transducers, position transducers, load, strain gauge devices, thermocouples, and all of that, all of those parameters are routed here into the cabin. This is primarily where the flight test engineers and our staff engineers sit, and they collect all that data that I just spoke about earlier. So they will sit and monitor via the screens as well as the strip charts. And these strip charts are really important, and they provide a time history of our data that's coming into the, for whatever particular test we're doing. They will evaluate that data real time to make sure the airplane's safe within its envelope and we're not stressing the airplane. Okay, so this is where our Rolls-Royce supplier partners will sit here and monitor their engines, the Rolls-Royce Trent 1000 engines. They monitor all the critical parameters that the engine can put out. These are our aft bank of water ballast tanks. And as I mentioned earlier, it's to control the center of gravity. So these may be completely filled to get an aft CG situation. Now we're at the aft cabin. You can see the large trailing cone winch. And the trail cone is meant to measure static pressure. So we send the hose with some ports at the end about 200 feet aft of the airplane. And we'll take that static air pressure and monitor it or compare it with the pitot pressure, and that'll give us a real accurate airspeed. Well, it's been a pleasure showing you the inside of the first flight test airplane. We in flight test already know it's a great airplane, and it's going to be even better for our airline customers. I feel honored and privileged to be part of the 787 team and want to thank you for allowing me to show you around the airplane today.
Cool. How was that? Did you guys imagine that to be that way? So in my role as an instrumentation engineer, I own every single device that is inside of that box. So I select equipment, I design equipment, design the architecture that we're gonna use for the data system, and so on. And if you guys saw those water barrels, cool. If you guys see those water barrels, they are designed to control the center of gravity of the airplane, because when we're flight testing, we have to have different conditions in which we try to emulate how the center of gravity is going to change depending on the different uses of that the airplane might have. Okay, so now I'm going to go into some highlights of test flights. Can you guys see my screen still?
Yeah.
Okay, cool. Is that I see this blue mark here? Okay. So Flutter. Have you guys heard of Flutter? Maybe some of you know what Flutter means, but when we talk about Flutter, usually there is a word that comes to mind, and it's oscillations, that is vibrations. And when we do Flutter testing, we try to find out which one are those nodal points in which the airplane start experimenting flutter, in which those nodal points in which there is instability, and we start seeing bigger and bigger and bigger oscillations. And what happened when there is flutter? I don't know how many of you took differential equations. And usually on your differential equations class, usually there is an example that is shown, and it's about the Tacoma-Verrazano Bridge, that in which the air that was coming through the bridge started creating some sort of oscillations, and the frequency of the air reached the same natural frequency of the bridge. And when you have an object in which their natural frequency is being matched by another force, there is some force, some air, some fluid, there is an oscillations that start happening, and it starts growing, and it can create a catastrophe event. So I'm gonna show you this old video as well. It is from the NASA. Maybe you're gonna laugh a little bit because it's an old video, but I think the images are pretty good for what I want you guys to see. Okay, it's a fan, it is a fan video, isn't it? Cool. So let me go back. Okay, because I got into this one. So every single airplane that every single new model, we need to perform flutter testing because we need to make sure that one of the steps to get a worthiness certification is flutter testing. Once the airplane gets fluttered, it goes through flutter and it gets a worthiness certification, then all of the participants can fly on the airplane. So usually for Boeing, we have several months in which we perform flutter testing, and we use telemetry to look at the data. So we have a telemetry room somewhere in Seattle in which we're looking at all of the data that is for the test conditions that are happening while we conduct flutter. And this is extremely important because we want to find out if there is any flutter condition, any nodal point that the airplane might see during any kind of flying, any configuration. So we try to identify those before we start flying on those, because we don't want to see ourselves in a situation in which something might snap. But there is plenty of testing that we do on flutter. And also, if you see on this NASA video, there is a lot of work that happens during the wind tunnels, because we try to detect as well with wind tunnel modeling a lot of those events before we start conducting flutter testing. And also there is a lot of simulation that happens before then. Okay, so there is another set of flight tests that we perform, and one of those is takeoff performance. Basically, what happens when we do takeoff performance, we want to assess and validate the performance capabilities of the airplane during takeoff. Yeah, we want to make sure that the airplane is safe and efficiently takes off as we expected it to be. There are different set of testing, different set of data that we want to collect. We want to be able to collect the distance that it takes to take off, the acceleration that the airplane takes in order to reach the takeoff speed. We want to identify engine performance and other stuff. Something that I love from this picture is that many years ago, that should be like around 2010, 11, I think, we performed a test in which we loaded a 747-8 with 1 million pounds. So it was a heavy airplane, and it was like the heaviest time that we put the 747 on a test flight, I think. Yeah, because we wanted to measure their takeoff performance and their performance characteristics for this airplane. Also, we have other testing that we call it abuse takeoff. For abuse takeoff, we have to keep in mind different configurations in which we might have pretty strong crosswinds, so we may have engine failures, so we have rejected takeoffs. So I put it here, engine out testing. So basically imagine a situation in which one of the engines fail, but we need to be able to keep flying with one engine. So that's testing that we perform to make sure that the airplane can fly with one engine, that it can land with one engine. So whenever you're in a situation that something might happen, by regulation, all of the airplanes are certified to fly without one engine. Also, we have another set of testing that we call brake testing. And during brake testing, we want to evaluate the performance and the effectivity of the braking system on the airplane. Yeah. So there are a set of testing that we do. We need to test the anti-skid system. We want to identify the brake temperature, and also we want to perform some testing for the emergency braking system. And when do we have an emergency situation? When we have a rejection takeoff, or maybe just imagine that the airplane was about to take off, found out about something, and it needed to slam the brakes and needed to stop right away. And that's a situation in which we need to reject a takeoff. So the next video that I'm gonna show has to do with some testing that we did for brake testing and on a rejected takeoff. This one is a pretty cool one. Okay, I got a little sticky note here. Lots of preparation that comes into this. We need technical expertise, and we need to think quickly on our feet. Once we see the video, then we go into this, onto the preparation and the technical expertise.
There's few jobs as rewarding as those in Boeing test and evaluation.
Hey!
And getting a chance to test a brand new airplane just might be the pinnacle. Such is the case with the new Boeing 787-9 Dreamliner. And with any new airplane, Boeing must demonstrate that even when fully loaded, the airplane can safely stop a takeoff on short notice.
To certify the airplane, we make sure that the airplane can stop on the runway at its highest takeoff weight and its maximum speed.
Seems very unlikely this would ever happen. However, it is a requirement that we test this, and that's what we do. We test very extreme situations that we really expect to never encounter.
Those extremes include not only loading the plane to its maximum weight and accelerating to maximum speed, but installing brakes that are 99% worn.
We grind the brakes down to the thinnest that they can ever be. We deactivate one of the brakes to simulate that there's a failure. So, I mean, we go to extreme lengths to make sure that the test is the absolute possible worst case scenario.
It's a scenario that takes some intense planning.
90% preparation and 10% execution.
A very coordinated effort between test engineers, pilots, emergency crews, and airport personnel, to name just a few.
We've been doing landing performance and high-speed rejected takeoff performance for probably a month prior to actually conducting this endpoint, which is that max brake energy condition.
Look at this.
The moment of truth.
Bring the engines up. You notice that the airplane accelerates very slowly because it's very, very heavy.
Accelerate the airplane again to about 188 knots of ground speed.
And then once you get to the takeoff speed, you slam on the brakes.
The 787-9 makes a complete and safe stop. Now, it's crucial to monitor the energy, in this case heat, that is created from the force placed on the critically worn brakes. To simulate real-time emergency response, fire crews must wait 5 minutes before engaging with the airplane.
We are monitoring the wheels. The tires themselves deflate per design. They have devices called fuse plugs within the wheels themselves that melt under high temperature and then in a very controlled fashion release the pressure of the air, of the nitrogen in the tire, so they don't blow treads. We want to make sure that that occurs in a very controlled fashion.
Stopping distance to temperature to fail-safes. Boeing test and evaluation makes sure everything goes safely, exactly according to plan.
From a performance perspective, it was right on.
It's disturbingly unexciting.
And brings the 787-9 one step closer to the flying public.
Cool, isn't this beautiful? Yes. I love that testing because just imagine planning this test and you guys got to see this is not in a Boeing location. This was in some military base because we needed certain conditions for the runway. And we need to look, what runways in the country have those conditions and the length that allowed me to accomplish this testing. Also, in which airport I would interfere less, because just imagine we're creating an accident basically, and then if you have traffic that wants to go into this airplane, we have to create the less interference. And also we need to work with the fire departments. So there is a lot of work that happens, a lot of coordination, a lot of preparations, and everyone has to be on point in whatever they are supposed to measure. Because if I fail and I wasn't paying attention, replacing all of these wheels and replacing everything that I have instrumented will take me months. So everyone has to be very well prepared, ready, and on point with what they are supposed to do. There is a term that is becoming more on our lingo, and I don't know if it is being brought up to you in your classes, but it's about psychological safety. And it's what are those things that we put in place so we can feel psychologically safe or safer when we perform an act. And this is a new field that I've been learning a lot. And also you guys get to see how you can introduce psychological safety on the things that you do. That's pretty cool. Okay, other testing that we do is a wave vortex test. Yeah, so you guys see on this picture here, and you see these wave vortices here, these swirling air masses. So when you're on an airplane and you see the wings, usually on the wingtips, you're gonna see these swirling air masses going on the back, and that they are gonna create a disruption on the airflow. Yeah, if I'm just right behind. Just imagine if you guys are on a boat, and on those small boats, when you go to a river and the little boat takes off and you feel the swirl from the water, you feel push, or you might feel that you're gonna draw, I don't know. So same thing happens with an airplane. Yeah. So there is this, in this waveboard testing that we do, we want to detect how these swirls are going to affect the airplane on the back. How long does it take for these perturbance to dissipate? And then how long does it take for another airplane to come and take off? Yeah. So in some situations, if you are in an airport and you have an airplane taking off, another airplane taking off, usually you see that the people in the control tower, they have to wait a certain amount of time, and they cannot start sending an airplane just right after another airplane, because each airplane has different masses, different takeoff characteristics. So we need to want to analyze how another airplane might get affected by another airplane that is in the front. So there is some testing that we do to calculate that distance and the separation between airplanes. So this disturbance doesn't affect the other airplane. Also, many of you, I guess you guys have done any static test for your materials class. I guess you guys have to take a materials class. And you start stretching. Usually you take a probe with certain metal and you start stretching on a tension machine, and there is a point in which there is a break and that snaps. Same thing might happen with an airplane. So we want to detect the loading conditions in which a wing might snap, come out from the airplane. So that's part of the max wing loading test. And also there is some requirements that are established by regulations. And being able, I couldn't find that. There is one in YouTube for the 777. In the case of the 787, it didn't snap. Yeah, it stays going all the way up, but it never snapped. In the case of the 737, of the 777, it did. And I'm gonna show you another video that has to do with preparation for fatigue testing. So you know that you got a static test and there is fatigue testing. And usually in fatigue testing, you want to put an object into the amount of cycles life cycles that is gonna have during their during the life of use. So let's go to this one.
Though it's strapped inside a metal cage, this 787 Dreamliner is about to taxi out to the runway for its first flight. By conducting this takeoff, Boeing engineers start fatigue testing of the 787, a long and grueling process that puts the plane through more than 100,000 simulated flights.
Essentially, what we're trying to do is match the damage that an airplane would see over its lifetime.
Unlike static testing, which pushes the plane to extremes to see how strong it is, fatigue testing shows how the structural integrity holds up over time.
We're demonstrating the durability of the airplane, checking our structural maintenance procedures. So we do them first on this airplane before an airline has to validate that we do have inspection techniques where we can find any cyclical damage well before the fleet will experience it.
To simulate multiple flights, Boeing mounted the airframe onto a specially designed test rig and then connected more than 100 mechanical devices to the exterior, from the leading edge of the wing to the tail fin to the fuselage. With this setup, engineers in a nearby control room can direct the devices to apply loads to the plane, basically pushing and pulling on the surface over and over again.
So it mimics the ground air ground cycle.
We're going from taxi conditions to takeoff, cruise, landing, and again taxiing to the terminal essentially.
And because airlines will use the 787 on very different routes, stress analysts designed several flight profiles to recreate the range of conditions the plane is likely to face over its lifetime.
And when we come out here, we verify that our analysis said we see this. The tests, we did see this, therefore our analysis is okay.
From this day on, engineers will be testing the plane 7 days a week for 3 years. When it's all said and done, this plane will have flown about 3 times the number of flight cycles a 787 is likely to face. It's part of the exhaustive program to certify the Dreamliner.
As an engineer, it's a fantastic time.
There's a lot of pride involved to be part of a program like this and to help usher it into the public and see people flying it safely.
Another video. I love videos because they show more than what I can describe by words. So as you see, all of the setup that we have to do for these airplanes is because we need to emulate the different life cycles of the airplane. And as you heard, this engineer said that they are going to test this for 3 years. So it is nonstop every single day for 3 years. So it emulates what an airplane will see in a lifetime. Actually, he mentioned like 3 lifetimes. So that's pretty cool because they might find any failure mode, any structural damage, which is important for us. Okay, there is another set of testing, crosswinds. So usually you get to see those cool YouTube videos or those TikTok reels sometimes in which these airplanes are landing sideways. Those are crosswinds. And also we have some cold soak testing. Cold soak is interesting because, okay, Indonesia is tropical, but there are places that are not this warm. There are places that are freezing. If you go to Siberia or if you go actually any of these Nordic places during winter, they might have these very cold temperatures. And sometimes just imagine when you take your cell phone and sometimes it is super hot and your cell phone might stop working or it's super cold and suddenly it shows some warning. So we need to make sure that the airplane is going to work in these super cold conditions and that the systems are going to wake up when the airplane is being under these conditions. So just imagine that you're going to Siberia, the airplane has to stay overnight in these cold temperatures, and the next morning they need to take off. So they are going to wake up the airplane, they want to power it on, and everything has to come back alive. So there is some testing that we perform, and this one is very peculiar because we didn't go to Siberia, but we went to a place in a that has a huge refrigerator in which the airplane fit in.
Seeing a new airplane undergoing tests inside a hangar is normal, but when it's snowing at the same time, that's rare. You're looking at the Boeing 787 Dreamliner in what is essentially a giant freezer.
Well, you feel it when you first walk in, you take that first breath, and it just hits you. And
it feels like the way I would think Siberia would be. Definitely cold.
Yes, you better dress warm if you visit the climactic laboratory at Eglin Air Force Base in Florida. Thanks to a massive air conditioning system, temperatures here can plummet to as low as minus 65 degrees Fahrenheit.
And this is really the only place in the world we could go in April that would give us the cold kind of temperatures that we need. We've got a lot of new systems on this aircraft, and we want to make sure that it's all functioning properly in extreme situations, especially when it gets very cold.
Before the test can begin, the 787 goes through what's called a cold soak. Basically, it's left in the freezing temperatures for hours until the structure is cold enough. Throughout the process, engineers closely track the thermometer.
I just want to see how rapidly it's coming down, if we can figure that out.
Every degree counts because the test plan is very precise, one that the whole team reviews page by page.
We'll see where we are with the jacks, and as far as with the temperatures, we won't test until the temperatures are where they need to be for the data.
Meanwhile, on board the plane, the team has put up a makeshift tent in the middle of the cabin to protect the finely tuned instrumentation equipment. This is the one part of the plane that has to stay warmer than the outside.
So you don't see any loss of data. That's really why we're here, is to get the data, to figure out if there's any anomalies within our systems.
The wintry weather does present challenges along the way.
The fans aren't working. So we've got a multitude of pencils.
Once the plane reaches the right temperature, it's time to test.
Today we are starting up the airplane for the first time at minus 40 degrees. We're making sure all the airplane systems function, including the cactus and the hydraulics and the electrical system.
So we're here to validate that the airplane then recovers when we go to start it, so that our airline customers, when they're in a similar situation, they have confidence that the airplane will do what we said it will do.
Cool, minus 65 Fahrenheit. So that in Celsius is negative 53 Celsius. I don't know, you guys, that's way colder than your freezer. And so we need to make sure that every single system on the airplane is gonna work when power comes back on. Yeah, actually some note, the guy that was sharpening his pencil, he was using a pencil because his pen didn't work because of the cold temperatures, so it froze. Okay, other testing that we do is community noise, since knowing how much noise an engine and an airplane produces is extremely important. So there are some locations that we go to in which we do an array of microphones that are located in a huge field, and the airplane goes through it, and we try to detect the noise level that is produced by an airplane. So that's called community noise testing. And also there is another set of testing that we call functional reliability, and it's when we took one of our test airplanes before they go and start getting delivered to our customers to simulate how the airplane is going to perform in a real environment in an airport working for an airline. There are more testing that you can find. Actually, if you guys go to the Boeing YouTube channel, there are some cool videos in which you find some of these on some of these testing. So we have a flight load survey. I have another video that will show some of that one. We got a gauntlet testing. Basically, we try to simulate on the ground how all of the systems of the airplane are gonna be working on. Autolens, basically, this one is interesting. Usually I don't get sick on a test flight, but Autolens is the only test in which I get sick. And why? Is because when we are landing, when they start developing the algorithm For autoland, you're gonna feel, oh, that's what I think. You feel the sinusoidal wave of the equation that was designed for the autoland. So when I'm flying, I feel the sinusoidal wave 1, twice, 3 times. So the thing is that we're not landing just 5 times. We might be landing 20 times on a row. So we land, take off, we land, take off, we land, take off. At the end, I just feel that my body doesn't resist anymore. That's the only test that kind of makes me sick a little bit. So we have ground effects. There is some testing to determine how the ground effects affect the airplane, how the response of the airplane under ground effects. Airspeed calibration. We got stall warnings and characteristics. We get air minimum control speed, trim characteristics, maneuvering characteristics, cruise performance, climbs and descents, smoke testing, noise testing, RAD deployment, cold day test, hot day test, and engineering oxygen mass drop. So I think I'm going to try to speed up a little bit. Let's see. Okay. So we have a propulsion certification test that we get going. Propulsion is basically the heart of the airplane. What allows me to keep an airplane on the sky are the engines. So we need to put a lot of time in making sure that these engines work pretty well. So there are some testing that we perform on the engines for certification purposes. One is engine in-flight start. Let me see if I have, yes. I'm gonna call it here. So one is engine in-flight start. The other one is negative gravity. The other one is engine fuel suction feed. And the other one is high altitude testing. So engine in-flight starts. So as I mentioned before, just imagine that one of the engines fails, or for some reason it shuts down on the air. We need to make sure that the engine is able to start during the flight. So there is testing that we perform for engine in-flight start. Also, negative gravity. I love this testing, and you'll see why. And negative G, who of you loves roller coasters? I love roller coasters. Thankfully, I never puke, but I'm always good when I go to a roller coaster. Just imagine you're going into a roller coaster, not for 5 minutes. Imagine that test goes for 5 or 6 hours. And you're going on an airplane that goes up and down, and you're trying to collect data. And there are different things that we want to accomplish when we do negative G testing, or also we call it roller coaster testing, or we call it also fly low survey. It's a combination of all of these tests. And hold on, let me take some water. Okay, and when we go into a negative G testing, all of the forces, just imagine you're in a roller coaster, everything starts pushing, and you feel like, oh, I can keep my smile if I want to smile, and you have your face. Same thing happens with the fuel. The fuel is getting some force that is being exerted on it. And we need to make sure that the fuel system is going to stay in place, that is going to work fine, that all of the engine components are going to be working as we intended to be. Also, let me, before I show the video, let me go to this one. So the thing is that one, since all of the testing they relate to each other, just imagine that we lose power, and that there is a fuel pump that allows me to have that fuel going into the engine doesn't work because there is not electrical power. Then it's like, oh, what is going to happen? My engine is not going to work. But we have some type of mechanical pumps that are going to work in place, that work on engines, that allows me to have fuel getting pressure and getting pump into the engine so they keep working. So there is testing that we perform to make sure that there is no interruption, that there is always fuel going to the engines, and that the engines are always going to be working. Even if you might lose some power and you might not see some of the indicators, there is always fuel getting pumped to the engines and everything is working fine. And usually those cases is like you're going to see those during a stall. So if the airplane is stalling, you're going to see the airplane incurring negative G's, and you need to make sure that the engine fuel suction system is working, and some of that testing covers that up. So now I'm going to go back to show you the video that I want to display. I think this is a pretty cool video. Actually, I was on this test flight, but the camera didn't get me. Let's see.
Just putting away the carry-on bags won't be enough for this flight. These Boeing engineers have to tape or tie everything down, from their lunch to their laptop.
You don't have it clamped down, things fly in the air.
It'll literally go straight up to the ceiling, and it can come down and hit you on the head.
You see, this is no ordinary flight. The new Boeing 747-8 freighter is taking off to perform flight load survey. It's one of the most grueling flight tests for an airplane and for those on board. A strong stomach comes in handy. You'll understand why in 3, 2, 1.
Sounds like a roller coaster. So you go up, you go down.
It's a challenge to keep yourself strapped in, your computer, your notes, and make sure that you're watching the right things.
It might look like fun, but it's serious business. Flight load survey is designed to validate the structural capability of the airplane by putting extraordinary stress on the fuselage and wing. To do so, the test pilots perform extreme maneuvers, such as repeatedly pitching the airplane down and then pulling up, going from 0 gravity to 2 times gravity in seconds.
It is as much as you want to push in airplanes. I mean, some of the test points are up to 2.5 Gs, and in service, that's very close to what the overstress limit of the airplane would be.
Going to 2 times the force of gravity greatly increases the load on the 747-8, which is already flying at its maximum takeoff weight of nearly 1 million pounds.
As you start putting stress on the airplane, you'll see the wings will start bending up, and they're under tremendous stress.
Really what we're trying to do is take it to the outer corners of the design envelope and demonstrate that the airframe can withstand the flight maneuvers and at the gross weights that we designed it to.
In the cabin, the flight test engineers and structural analysts are trying to stay in their seat while monitoring the airplane's performance. These roller coaster flights can last 4 to 5 hours and are not for the faint of heart.
Because we do so many conditions so quickly, right? You kind of don't have time to, yeah, that was great. You got to concentrate on what you're doing, right? Because you got to be ready for the next one.
A grueling test to make sure the new Boeing 747-8 freighter can handle loads far beyond what it will face once in service.
Airplane handled great, easy to fly, well behaved, and just did a great job.
Cool. What do you guys think? So that's what I love, roller coasters. There are many things that we test on these flight load surveys, roller coasters, is because we basically want to look at the structural integrity of the airplane, plus all the requirements that we got for propulsion. Okay, cool. There is some. I was trying to look at what cities, which one is the highest altitude city in Indonesia, and it seems that the highest one that I found was Bandung. I think that's how it's pronounced. That is at 758 meters. I grew up in a city that is way higher. That is 2,600 meters. Yeah. But also, so I'm gonna put an example with my father. My father, he had a car from 1970, and that car was an old car, And at that time, the cars have a carburetor. And the carburetor, so we live in a high altitude city in Bogota, which was 2,600 meters. And I remember when he wanted to travel to a place that was closer to the sea level, he needed to go to the carburetor and modify something because he needed to change the proportion of oxygen that goes into the carburetor for combustion purposes. So you know that for combustion there is a relationship between oxygen and fuel, but that relationship changes with altitude as well because air density changes. So the density, the amount of oxygen that you find in high altitude is lower. Same thing happens with an airplane. Not same thing, but it goes under the same circumstances in which, okay, if we fly at sea level, the characteristics for takeoff are always the same. The engines always see the same oxygen. But if I need to go to the highest airport in the world, I need to make sure that the airplane is gonna work there as well. And there are one of the two, if I'm not mistaken, one of the two highest airports in the world is in La Paz, Bolivia. I think the other one is in, if I'm not mistaken, maybe in Tibet. I don't remember the name. So we go and perform testing here because this airplane, the elevation in meters, since you guys are familiar with meters, is 3,800 meters. So it is quite high up. And we need to make sure that the airplane flies and takes off, and there is a whole bunch of propulsion certification testing that happens there. So things that are pretty cool about going to different places. So in this place, when we go to Bolivia, I try to go to Bolivia because I speak the language. I speak Spanish. That's my mother tongue. But when you go with a team of 80 people, in which the only person that speaks the language is you, or maybe other one or two people, then the logistics become quite interesting. Because at this altitude, people may get sick. Many people get sick because of the altitude. You cannot even walk. Suddenly it's like, how come I cannot even walk? What happened to me? And your heart starts pumping. So there are other logistics, other planning that goes when we go to certain places. And this is one of those. And something that I love is because I'm able to communicate in Spanish and in English in engineering terms. I also did some engineering in Spanish. And for me, it's been awesome. And high altitude testing is part of the certification that we do for propulsion, for the engines, to make sure that they work at that altitude. So once we have certified a set of engines for that altitude, they are certified to work to take off from that altitude or any lower altitude. So usually that's why we try to go to the highest airport that is available for this testing. Okay, so I have explained different types of flight tests. The one that is usually for certification purposes, the one that is related to propulsion, and another one that I'm gonna do some examples of a platform that we use that we call the Eco Demonstrator. And basically it's a place where we perform different type of testing. The idea is to reduce the environmental impact, but also we want to showcase other projects that we're working on. So these ones are some examples. I put this one because I was a participant of this test, so I know what happened in each one of those. I think I'm gonna go to this one. This one was a pretty cool test that it was in a partnership with NASA. And basically, okay, when you go on a long drive, just imagine you're in a car, you go on a long drive, and usually after a couple of hours of driving, not in the city, but you go countryside per se, you're gonna start seeing mosquitoes, insects getting in the front bumper of your car. The same thing happens with an airplane. There are bugs that you find in the first hundreds of meters on the air. And what happened is that by having insets, they might interfere with the laminar flow of the wind profile. So there was a test that we did with NASA, in which NASA developed 5 different types of coating to be placed on wings to see which one wouldn't accrue insects during all of these conditions. So the idea is to reduce insect accretion and keep the natural laminar flow on the wings. That's not something that anyone might think of, but that was a pretty cool test that we did. Yeah, we went to a location in Louisiana. It was Shreveport, Louisiana, and we went there because at that time of the year was the location that had the highest amount of insects on the environment. So that was some cool test that was for R&D purposes. Another test was that we performed, also was another partnership with NASA, was airflow control. And the idea is that by creating an energy momentum on the vertical fin of the airplane, how we could improve the aerodynamic efficiency of the rudder. So we got our findings. We have different jets. We have I don't have a picture of that, but let's say that we have different jets that created momentums all along the way of the vertical fin, and the idea was by having those momentums how we could reduce the height of this wing. Yeah, so there was the good results based on this research. Well, let's say that it was interesting to see that happening. The setup of producing an airflow control system on an airplane, it takes a lot of space and oh yes, I can see actually. If you guys see on this picture, we had a heat exchanger here, in which we were pumping air. It was a hotter air that we try to cool down using these heat exchangers, so we could got it through different streams along the wing. Actually, I think if you guys go on the NASA website and look for airflow control, you might find some information. Also, since we got many airplanes that are built with composite materials, we were trying to look at ways of recycling carbon fiber for 3D printing. So we were having some of those projects. And also, let me see. Let me go to another picture that we got here. There was a pretty cool one. This one here on this seat, in which we have we call it the energy harvesting electronically dimmable window. And basically, we know that the 787 has dimmable windows, but also one group was developing this solar panel that was transparent, that was placed on top of the wing. The idea was to create the energy that the same window needed to perform its dimmable functions, to be able to have the power to dim itself. So those are some of the projects that we do in experimental flight tests. So we go from the regular certification test flights to everything that goes in research and development, or any other thing that gets thrown to us in which someone wants to test something on the airplane. And what's the end of the goal for us is to have a safe and certified airplane. So before I go, let me see. I have a last video here. So let's see what time it is, and then we go into a Q&A.
An all-new airplane, you go on so many flights, work so many weekends, they start to blend together. But for these Boeing pilots and engineers, this Saturday morning is one to remember. They're preparing to finish the last test required to certify the 787 Dreamliner.
Getting to the point where we've worked so hard for so many years to finally get to the point where at the end, it's just unbelievable.
Just as the fog rolls in, the team sets off from Everett, Washington to complete function and reliability testing, where they'll put the airplane through more airline situations. It should be a breeze compared to what the 787 test fleet has already been through. Boeing put one Dreamliner into a refrigerated hangar to see if it can start up at minus 45 degrees. On the runway, pilots put the tail down on the ground to measure how slowly the 787 can take off. They slammed on the brakes while the jetliner was speeding down the runway to simulate the ultimate rejected takeoff. In the air, pilots flew the 787 at the lowest possible speed, then up to almost the speed of sound. They purposely put one Dreamliner through hundreds of stalls to make sure it can recover in such an emergency. In other flights, some of the most extreme loads were placed on the airplane to test for flutter. Upon landing, the 787 had to handle fierce crosswinds, wet runways, or just fly repeated passes to test for ground effects.
This is all done to demonstrate the robustness of the airplane in the event of almost anything that could happen to it. And in every case, the airplane has achieved exactly what we've desired.
The 787 is a revolutionary design, with its extensive use of strong but lightweight carbon composites, more electric systems, and advanced aerodynamics. All those features had to pass certification requirements. To date, the 787 test fleet has flown just over 1,700 flights, racked up more than 4,800 flight hours, and performed more than 25,000 test conditions. Pretty much everything imaginable.
I'm used to landing the airplane 100,000 pounds overweight. I'm used to flying it with the overspeed warning going off for hours on end, or flying the airplane with an engine turned off.
After flying around the western U.S. for 6 hours, the team brings the 9th Dreamliner back to Everett. Everything went according to plan. So with the sun now shining, it's time to land and make aviation history.
When the airplane landed, it had with it all of the hopes, the dreams, the hard work of the tens of thousands of men and women of Boeing and our partners around the world who have labored so long and so hard on this airplane.
For 787 Chief Pilot Mike Carricker, who was in the flight deck for the first and this last flight, it's a long journey worth savoring.
To look at all those features working together seamlessly, and you understand all the work that it took to get there, you're just so proud of the tenaciousness of the team that put it together, and you wish you all could have been there to watch it.
Cool. So, any questions for me? So, what do you guys think of this presentation? I try to include a lot of images, a lot of videos, because there is a say that images speak louder than words, and sometimes it's easier to explain certain things. And also trying to do a mix of this with the presentation, with my insights, it makes it more enjoyable. So, any questions from any of you guys?
Okay, well, thank you very much for your enthusiastic presentation, Mr. Diego. I know that you love what you done. Okay, we have some time for some questions from the audience. We have Fahri. Fahri, do you have any question for Mr. Diego?
Yeah.
Yeah, please.
Okay. Thank you for the opportunity. Hi, Sir Diego. It's nice to meet you, even if it's online. It's an honor to meet. My name is Fahri. I'm a final aeronautical engineering student here from this university. It was a great presentation, sir. Especially when it comes to very specific, like technically, when you were talking about the differential equation for the oscillation. Also, when it comes to generally with the flight test, and I was thinking about two questions, but now my question is just one left, because one of the questions has already answered by your presentation regarding the environmental test. Since we know theoretically all structures such as specifically metal and avionics and all systems are affected by the environment, and it was so cool that realizing that Boeing has a climatic laboratory. That's so cool regarding the climatic laboratory. And so I would like to ask some news. A couple of days ago, I read some news from the reportation from CNBC Indonesia. The newest Boeing airplane with 777X, given that recent structural issue with the 777X cross-link with the engine and the structure connected. And how is Boeing integrating findings from these experimental flight test failures into the development of the structural repair manual with SRM and SBs with service bulletins? Specifically, what steps are being taken to ensure that airlines have the necessary guidance and resources to address similar structural concerns in the future?
So remember that this, yes, can you hear? Yes. So remember that so this one was on a 777X airplane. So this one is not out in any airline. No one has it, only us. So by being an experimental, so this one, remember which one was one of the goals of experimental airplanes, of flight testing, is trying to discover any issue or any design issue that might happen. So that's part of flight tests. That's what we expect, to find which one are those things that might fail, that might need some redesign. Yeah. So I'm not involved on the fix or on the work, but I know that Boeing has set up many teams that are working on the situation right now. But I think that's part of flight tests. We want to see things coming up, and we're glad that we get to see those situations. Yeah. But Boeing has teams working on it. And you're talking about the design manual. So since this one is not an airplane that is out in the market, yeah, so there is no any design manual that is being produced for this airplane yet. So whatever it is included on this airplane, my guess is that this is going to include a redesign of the part. So it's going to have a new part that will be in place of this one. That's what I imagine. Yeah. But remember, once the airplane is out, then everything gets incorporated in the maintenance manual. But it is not an airplane. It's a different story. It's a different treatment when an airplane is already in the market and the airlines already have it. But this one, no, there is no airline. The airplane is not certified to be sold yet. So when that happens, then it's a different story. But at this point, Boeing is working on the issue.
Okay, thank you, sir. Once again, it was a good presentation. That's all for me. Thank you.
Yeah, no, anytime. Thank you.
Okay, thank you, Fahri, for the questions, and thank you, Mr. Diego, for the answer. Next, we continue to the next questions. Anyone else? Is there anyone who want to ask Mr. Diego?
Can I ask question?
Sure.
Yeah, please.
Hi.
Who
Hi,
is
Diego.
it?
My name is Tia Utomo. I'm a lecturer at International University Liaison Indonesia in Serpong. Hi, Diego. I'm very enjoying your presentation, especially for all of the film that you present to us. Just wondering, is the film available in the YouTube, or is it only for Boeing documentation? Can we have the film in YouTube? That is my first question.
Hey, yes, what I can do, if you guys want to see all of the videos, I can send you guys all of the links. All of the videos that I presented are in YouTube, and that's what I wanted to create, something that people can go and find the same videos that I'm showcasing. Yes.
Okay. Thank you very much. And then the second question is, if I'm not wrong, that usually the company that performing the flight test have not only have one prototype, but they maybe have a 4 or 5 or 7, maybe more for the prototype to do all of the flight testing. My question is, what happened with all of the prototype after the aircraft has the type certificate? They are just dismantled, or they just sell it to the customer with special price for that one? because the last one that you mentioned, that you performed the last test to complete the certification, they already have the ANA label on the vertical tail. So I assume that this is already customer aircraft.
Yeah, so just imagine all of the testing that these airplanes undergo. It is crazy. So sometimes the intent many times is to be delivered to certain airplanes, I mean to certain airlines. But usually what happens is that these airplanes, they got so many configuration changes, so many modifications, a lot of testing, a lot of software updates, many things happen to these airplanes that, for instance, in the case of the 787, I think we have 6 airplanes.
6 airplanes.
For flight testing.
Okay.
Airplane number 1, I think it's in the Museum of Flying in Seattle.
Museum.
Airplane number 2, if I'm not mistaken, there is another airplane, one of those 6, that went to Japan and is also in another museum in Japan.
Okay.
There is another airplane that went certain location to be sitting over there. Airplane number 4, we still use it for testing. Airplane number 5, I don't remember who took that airplane. And I think airplane number 6, when there was some country that wanted that was sold to a certain country. Don't remember well. But many of those airplanes, they ended up going to museums, or we keep having them for testing. Yeah.
Okay. Thank you very much. I enjoying very much your presentation, and I'm looking for the link that have for all of your film.
Okay, awesome. Thank you. I really appreciate it, and I'm glad you enjoyed the presentation.
Okay. Bye-bye.
Okay, thank you, Mr. Setio. Is there anyone else who want to ask? Please raise hands. Okay. No?
If there is no question, I have one question again.
Oh, yeah, okay. Please,
Okay.
Mr. Setio.
Okay. In the internet, I found that for the one kind of the aircraft, if I'm not wrong, they spend about 2,500 flight hours to do the flight testing. That is the cumulative of the all 6 aircraft, or they are only for the one aircraft?
I think the number should be for all of the 6 aircrafts.
All of the 6 aircraft. All of the 6 aircraft.
And actually, you were asking me, I think you tried to ask me, is that, okay, we have different airplanes, and we try to split a lot of we condition certain airplanes for certain testing. So let's say I'm going to focus an airplane on propulsion. So that airplane is going to be heavily instrumented on the engines. Another airplane is going to have a focus more on environmental control systems. So I'm going to have more of the DOTS and more of the ECS system heavily instrumented compared to the other airplanes. So we try to customize certain things on the airplanes. And also in the case of interiors, as you saw, not all of the airplanes have interiors, have seats, have all of the ceiling, but we try to keep a couple of those airplanes with interiors to collect some data as well, and to have some data points.
Okay.
Yeah.
Okay, thank you very much. And about the cable, you mentioned about the orange cable. That is a wire cable from the optical one, or is it still in the in the metal or kind of that one?
So orange cables, actually, that's an international convention for flight tests. So usually on an airplane, if you have an orange cable, it's a cable, a wire that was installed for flight test purposes. And usually in our case, we fabricate our own wire bundles.
Okay.
Yes.
And I mean, there is came from the fiber optic, or there is still use the metal kind like that one?
It depends on the application. So you have many copper, you may have some coaxial cables, you may have the regular copper cables if it is for Yeah, copper cables, and in some applications, we might have data that is going through fiber optics.
Ah, okay. And how many parameters do you have for one big aircraft like that one? 787, for example.
I can't say. So I tested, I was part of the team of a 747, and I remember, I'm not gonna say the exact number, but let's say that it was in the order of thousands. Just imagine thousands
Thousand, and
parameters.
every time, every one single parameter have one cable.
Yes. No, every single, because there are so on testing you have data that comes from the buses and data that is analog data that is coming from instrument from transducers. So, but you have the amount of weight that you introduce because you got all of these transducers everywhere is a lot.
Thank you very much. Thank you.
Yeah.
Thank you.
Yeah, Mr. Setio, thank you very much for your questions. Maybe I have one question for Mr. Diego. Mr. Diego, you talk about the tests of flight tests. There are several tests, right? So I want to ask how many percentage flight test costs compare for overall aircraft design and development costs? So
You
about
got
range.
me. Oh, you got me on that one. You know what? I need to look into it because I don't have an answer right now. Yes, you
Okay.
got me. You got me on that one. And I think every single program is different. Yeah, no, you got me. I have to say you
Okay.
got me. I don't have a
Okay,
number for
because
you.
there are so many flight tests, right? Okay. I want to ask another one questions. You talk about the negative G test, right?
Yes.
Sometimes I got confused about the negative one is going to up or going to down. The negative G.
Okay, so going up. So
It's
imagine.
going up.
Okay.
Yeah, please.
If you are the object that is in the airplane and you are the one that is feeling that force up, that's negative. So remember that the direction of gravity is going down, right? And that's the same positive direction of the gravity. So if I'm going against it, it's a negative G. That's in terms of just imagine if you're in an elevator and the force that you feel as the body inside that elevator is going to be up.
Okay, going to the center of the earth, it's positive, right?
Yes, that's correct.
Okay. Okay. Thank you very much for the insight. Okay, we continue to the next questions. Is there anyone? Maybe one question more?
Can I, if there is no, I will have
Okay.
question.
Okay, Mr. Setya, please.
Yes, just wondering about the trailing cone that you mentioned in the first film.
Yes.
Okay, that. How about the tube itself? It is made from what kind of the tube that it can sustain the load that came from the cone itself, and then but there is still have the pressure itself. Is it sent to the aircraft by using the pipe, or they send it by the signal conditioning, or kind of that one of using the
just
tube
imagine
itself?
so I need a board. So this okay you have this winch, and what you see is a hose. It's a plastic hose. I'm not going to say the material of the hose.
Okay.
But you have a hose, and when you unroll, when you extend the winch, that start coming out from the vertical fin. Let's say that you stand it, depending on what you're trying to look, let's say you stand that hose 200 feet out. So what you're trying to gather there on that at the end of that hose is the static pressure in that location. And by being a static pressure, it means that everything inside the hose it stabilizes, and what you measure from a pressure transducer that is inside the airplane, at the end of the other side of the hose, is going to be the same static pressure that you see on the air. We got some calculations for losses and...
My question about the hose itself. It is a special hose, or it is the ordinary hose that you can find it from the market?
Because it is ordinary. So it has certain characteristics, but you find that in the market. It's not... yes. It has certain characteristics, some properties that you find. It's not fabricated. It's not made by us. It's made by a supplier that we contact. And yes.
Okay. Thank you very much. Thank you very much. Thank you very much, Diego, for your information.
Okay. We come to end of this lecture. I appreciate your detailed explanation, Mr. Diego. We are grateful to Mr. Diego for sharing your knowledge with us today. Your presentation has undoubtedly enhanced our understanding of experimental flight tests and its importance in the aviation industry.
Thank you guys for inviting me. It's been a pleasure having this time with you guys. I wish it was on a physical setting that I could see people's faces and I could go, hey, tell me about this. Hey, tell me about that. What do you find out? Yeah, but it's always pretty cool to be here.
Okay, this concludes our lectures. Thank you all for attending. With that, I would like to hand the stage back to our MC to continue the program. Please, Ms. Rizka.
Thank you very much for Mr. Bernal and Mrs. Syarifah for the great lecture. I wish the whole series of events for today have been completed. Thank you to all participants who were willing to attend and enliven today's public lecture event. We hope this event can provide benefits and a deep impression for all of us. On behalf of the committee in charge, we apologize for any shortcomings in today's event. Final words, good afternoon and see you for the last lecture series with Boeing Indonesia Association next week. Thank you very much. You may leaving the Zoom. Thank you very much, Mr. Bernal.
Thank you, guys.
Thank you very
Buenas
much, Mrs.
tardes.
Veronica.
Bye-bye. Thank you.
Thank you very much.